Hello everyone. In this video we are going to discuss a very important topic, that is vector additions, how vectors are added. So there are different ways and means by which we can add vectors. Some of the ways in which we can do that is triangle law of vector addition, then parallelogram law of vector addition, and polygon law of vector addition. So in this video we are going to have a brief discussion of these three different ways of vector addition, and we will first start with the triangle law of vector addition. So let us see what is triangle law of vector addition. Suppose two vectors are given to you, any possible direction. Let this be vector A and vector B. Okay. Now these two vectors, vector A and vector B, if they are taken such a way, both in magnitude and direction, like this is vector A, whatever length of vector A is there, the same length is taken here and same direction. Similarly vector B, whatever length is there and the direction, the same length and direction is taken here, and they are taken in the same order. You can see it is in the anti-clockwise direction. Both of them are in the same order. Then the resultant is given by that is the resultant of vector A and vector B is given by the third side of the triangle, both in magnitude and direction, taken in opposite order. You can see these vector A and vector B are taken in the anti-clockwise direction, but this is taken in the opposite direction, vector R, which is the resultant. So what we can say is, if two vectors A and B as shown here are represented both in magnitude and direction by the two adjacent sides of a triangle such that they are in the same order, then the resultant is given by the third side of the triangle, both in magnitude and direction, which is taken in the opposite order. I hope this is very clear to you. See, if two vectors can be represented both in magnitude and direction, that means magnitude has to be same. Say here vector A is there, here also the same length and direction, that is same magnitude and direction. Vector B also has same magnitude and direction. They are represented by the two sides of a triangle taken in the same order. You can see vector A and vector B are taken in the same order. Then the resultant is completely represented both in magnitude and direction. Okay? That is the resultant here, vector R, which is the resultant of vector A and B, both in magnitude and direction, by the third side of the triangle, but it is taken in the opposite order. You can see this is in the anti-clockwise direction, but the resultant is taken in the opposite direction. So this is known as the triangle law of vector addition, where two vectors which are given to you, you have to make them the two sides of a triangle taken in same order, then the resultant will be given by the remaining side of the triangle taken in the opposite order. Here, according to the triangle law, therefore what we can write, the resultant, that is OQ, is OP, that is vector A, plus PQ, that is vector B. So vector R, which is the resultant vector, is given by vector A plus vector B. So this is the representation of the resultant vector R, which is the sum of vector A and vector B. Now the next proper way in which we can add the vectors are parallelogram law of vector addition. Suppose again two vectors are given to you, vector A and vector B, and you have to take these two vectors to be the two adjacent sides of a parallelogram such that they are co-initial. If you remember, co-initial means they start from the same initial point. So if we have to represent it by two sides of a parallelogram, you can see here vector A and vector B, such that they are co-initial. Their starting point or their initial point is same, O. then the resultant is given by the diagonal of the parallelogram passing through the same co-initial point. I hope this is clear to you. I repeat this again. If two vectors can be represented both in magnitude and direction, length and direction of vector A and B, the same length and same direction of vector A and B are used here. They are represented both in magnitude and direction by the two adjacent sides of a parallelogram drawn from a common point. This is the common point O. Then their resultant is completely represented both in magnitude and direction by the diagonal of the parallelogram drawn from that point. You can see here there are two diagonals. One diagonal can be in between P and Q, but we have to take that diagonal which passes through the co-initial point. So the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through the same co-initial point. Actually, you can see here, if the triangle law is correct, then parallelogram law will also be correct, because this vector B can be represented here also. And if this is represented here, then this vector R is the resultant of a triangle law of vector addition. So triangle law and parallelogram law, they actually represents the same thing. In triangle law, we consider a triangle where the vectors are taken as the two adjacent sides of a triangle taken in the same order, whereas in case of parallelogram law, the two vectors are taken as to be the two adjacent sides of a parallelogram such that they are co-initial. The resultant is represented in the same manner. You can see here the resultant is OS, which is given by OP plus OQ. That is vector R, that is the representation of the resultant. Vector R is equal to vector A plus vector B. Now the third way of adding the vectors. Till now we have considered both in triangle as well as parallelogram law only two vectors, vector A and vector B. Now we are considering many number of vectors. Let those vectors be given by vector A, vector B, vector C and vector D. Now we will place them in such a way then that they becomes the sides of a polygon. Then the resultant will be given by the closing side of the polygon taken in opposite order. If earlier all the vectors are taken in the same order, then this vector R, which is the resultant, will be considered in the opposite order. So we can say here, if a number of vectors are represented both in magnitude and direction, you can see here vector A, vector B, whatever are the directions and whatever is the magnitude, same magnitude and directions are taken here. Like vector B, you can see vector B, same direction. Vector C is here, it is also taken in the same direction, same magnitude. So if the number of vectors are represented both in magnitude and direction by the sides of an open polygon taken in the same order, that is very important, it has to be taken in the same order, then their resultant is represented both in magnitude and direction. We are talking about this resultant, magnitude and direction, by the closing side of the polygon taken in opposite order. This is the opposite order we are considering here. Now we can prove it also. Like from the triangle law, if it is correct, we have seen that it is parallelogram law is also correct. Now from the triangle law also we can prove the polygon law here. That is, suppose vector A and vector B. So this is the resultant vector A plus B. Now this resultant vector A plus B and C, here we get the resultant again, that is vector A plus vector B plus vector C. Now along with D, we are using the triangle law. So here we are getting vector A plus vector B plus vector C plus vector D, which is the resultant vector. So if the triangle law is correct, by using the triangle law we can explain the polygon law also. Here the same steps are given, you can go through the steps. Finally we are getting the resultant, which is vector A plus vector B plus vector C plus vector D. So I hope this is very clear to you, the triangle law, parallelogram law and the polygon law. And if you are clear with the triangle law, then parallelogram law and polygon law will automatically be clear. I hope that there is no doubt, but still then if there is any doubt, you can post me the doubts. Thank you.